In this video, we're going to look at the idea of some simple cryptography, specifically the Caesar cipher. Now, the need to hide the meaning of different sets of information has been around since pretty much as long as language has been invented. People have used various different codes, symbols, and other methods to have this ability to hide the meaning of that information. And when we do this, the practice is called cryptography. And today that idea incorporates skills from mathematics, both computer, mechanical, and electrical sciences. So it can be purely electronic, and it can also be a mechanical method. One early form of cryptography is the Caesar cipher, and that was named after the Roman Emperor Julius Caesar. This method of encryption and decryption uses what is called a shift cipher. Now we start by writing out the alphabet as we normally would. Now we must decide on how much we need to shift the alphabet, and this shifting is why it's called a shift cipher. So this value is known as our key. It's very important you do not forget your key. If you do, then you will not be able to easily decipher or decrypt your information. So let's, for this example, use a key value of 4. And we'll put that over the side here. Now let's start thinking about the letter A normally being at the position 0. Now we use 0 for a few reasons. Firstly, because it works really well with computer science, where we don't want to waste that 0 value. We want to always use all the values in a list. But also we can think of it as having not shifted. There's 0 shifting of the letter. So if we start first of all with the A in its first position, position 0, we have not shifted this alphabet. But let's now shift it by 4. So we'll start with it at A and we'll shift it across to the 4th position. So remember, the 4th position is actually 5 letters in, A being the first letter, but it's in position 0. Then we've got position 1 where B is, position 2 where C is, position 3 where D is, and position 4 where E normally is. So we're going to move our A across to the 4th position. Now we go ahead and fill in the rest of the alphabet until we get to the end. So from the A in the 4th position, we fill in the B, C, D, and so forth until we get all the way up to the Z position, the 25th position. Now we go back to the start and fill in the leftover letters. So essentially what we've got here is the alphabet starting at position 4 and wrapping around back on itself so that all the spaces are filled up. So again, this is why we say that we are shifting the letters, because we have moved them across. Now we can use this Caesar cipher to encode and encrypt a simple message. So for this example, we'll use the message hello, Hello. In this particular cipher, notice also that we don't have lowercase and uppercase letters, and we also don't have punctuation, spaces, or anything else. So all we're concentrating here is the most simplest case, where we just have the letters themselves. So we'll start by finding the letter H in our top row, the row that has not been shifted. So this is our normal alphabet. So here it is, H is in the 7th position. We're now going to look in the bottom or the shifted row to see what the encrypted value would be. So if we look straight below it, we see that the letter in the 7th position is now the letter D. So our encrypted value for H is the letter D. So as we said, the H is represented by the letter D, but it's very important to remember that this is only true when we're using the value key for number 4. If we change the key value, then of course H would be represented by a different letter. So it's very, very important that we always know what key value we're using, and that we don't change key value during the encryption or decryption process. Otherwise we will get gibberish and just rubbish answers. So now we're going to do this for the rest of the letters in the message hello. So we've done the H. Now we're going to do the E. So we start by looking in the top row for the E. It's in position 4. We look directly below it and see which letter is in our shifted alphabet, and that is the letter A. Then we're going to look for the L. So looking at the top row, we see that that's in position 11. We look directly below it and see that that's actually represented by the H. So the encrypted version of L is a H. Now we've got a second L, so we don't have to look anywhere different. We already know that that's going to be represented by a H. And then finally, we're going to look for the O. So we look in where it is in the top row, in position 14. We look below it to the K, and that is our encrypted version. So what we have now done is we have encrypted, using a Caesar cipher with a key of 4, the word hello, which comes out as DAHHK. Now, if we received the encrypted message, DAHHK, we would need to know the key to be able to decrypt it easily. Now, one thing to note that the Caesar cipher is a very simple cipher, and there are some very easy ways to work out what a key might be without knowing it. And that's a challenge that you might actually have for you later on, is to try and work out or decrypt a message without knowing what the key is. But for now, let's just assume that you must have the key to be able to decrypt the message. So here I have that message, DAHHK, and I need to know the key. So we're going to do the same process basically in reverse. So here is our key 4, just like we had before. Okay, and now we write out our alphabet just like before. So this is our non-encrypted, so just our normal alphabet, starting at position 0 with A, position 1 with B, and so forth. We again move our A across to position 4, just like before. So really all we're doing here is setting up the table to show our encryption, putting out the rest of the letters, wrapping it round, and we are back to having a table that will give us what letter is represented for each encrypted letter for the key value 4. So let's now start decrypting our message. So as we said earlier, it's basically just the reverse. So instead of looking at the top row and then looking at the bottom row for the encrypted version, we're going to start by looking at the bottom row and then looking at the top row for the decrypted version. So let's find D in our bottom row. Here it is in position number 7. We look above it into the non-encrypted row and we see that as being a H. So the decrypted version of D is a H. And we do exactly the same process as before. We look at each of the letters in DAHHK, and using this table with the key value 4, we can find each letter. So we look at the A in the bottom row in the encrypted version. We look above it for the E, which is the decrypted version, and we write that down. We do the H, same thing. Look above it for the L. Again, we've got another H, so we know that must be an L. And we finally do the K, finding that in the bottom row, looking up the top and seeing that's an O, and I've now decrypted my word. So DAHHK with a key of 4 is decrypted to be hello. So again, in both cases, it's about, first of all, knowing what key value you're going to use. It's about setting up your table properly, so shifting your alphabet by the appropriate number to match your key, and then either looking at the decrypted version, and then finding the encrypted version, or the other way around if you want to decrypt some information. Now, writing out the alphabet for every possible key takes a lot of time. So we can create a mechanical device that helps us, and we call this device a cipher wheel. So here we have the 2 parts of the cipher wheel, and if you haven't already done so, you can collect these from your teacher or print some out for yourself, and you can make your own cipher wheel. So we'll start by saying that the bigger or the outside wheel is going to represent our unencrypted values, so the normal alphabet, and the smaller wheel is going to represent the encrypted values, and we've got that written on the screen there. Now what we're going to do is place the smaller wheel on top of the larger wheel. Then using a pen or a pin or something like that, we can poke through the 2 holes together so that we can put through a split pin. If you haven't got a split pin, then you can just poke anything through that you like, or just basically hold them where they are, but it's obviously easier with a split pin because it can rotate. Now, when you put your split pin through, it's a good idea to put a bit of tape over the legs on the back of the pin. It just helps to stop them peeling up or getting caught on things or poking you. It just makes it just that little bit safer. Also, a good idea to write your name and your class or something similar on the back of it, just in case you lose it or leave it lying around, that it can get given back to you. Now, once you've done all this, you want to test that the inner wheel rotates smoothly and freely around, so just give it a bit of a spin. If it's the first time, it might be a little bit tight as you sort of twist in the split pin a little bit, but it should be able to freely move around. Now, what we need to do to use it is rotate the inner wheel so that the key value lines up with the grey outer A. So the A, again, on the outer wheel is our starting point, our 0 point, and what we'll need to do is use our key value and rotate it around. So like before, let's say we're going to use the value 4. If we look at the inner wheel, you can see the first few numbers have been provided. So A is 0, B is 1, C is 2, and so forth. So you'd count around until you found position 4. So it would be A, B, C, D, E. So E would be position 4. So not the fourth position, but position number 4. If it helps you and you really need to, you can go around and write all the numbers on the wheel, but just the first few have been provided in this example. But we'll rotate this round now so that the fourth position, the E, is lined up with our original position A on the outer wheel. And this has now set that code. So if you were to look back at the previous examples where we wrote the alphabet out, you would see the same matching pairs, where the letter A in the alphabet is now encrypted as an E. The letter B is encrypted with an F, C is encrypted as a G, and so forth. So you can look around and see each of those pairs. Now, another good idea is it's often helpful to put a paperclip over the A just to help keep the key aligned. This helps to stop you from accidentally turning it while you're using the Cipher wheel, and it also just makes it very clear that you've lined those up properly. Again, it's not required, but it does help just keep things a little bit more steady. Now, once we've got this wheel all lined up, we can go ahead and, as I said, use that same tool to encrypt and decrypt a message, encrypting by finding the letter that we have on the outside wheel, then getting the encrypted version from the inside wheel. And if you're trying to decrypt a message, you start by looking at the inside wheel and then looking out to the big wheel to get the original letter. It works the same way as writing them out. It's just more convenient to do this because we can adjust it to any of the 26 possibilities very easily instead of having to write them out or have a book of all 26 sets of combinations of letters. So a cipher wheel like this is a very easy and simple tool to make to do some basic encryption and decryption. So off you go. You can read the wheels to, as I said, encrypt by looking at the inner wheel, or to decrypt by looking at the outer wheel. So I'd like you to go off and use that to do some encryption. You can either try worksheets that your teachers provided you, or you might just like to encrypt some things of your own, such as your name, maybe family and friends, and just practice using the wheel. Thanks everyone for watching as always. Please rewatch the video if you need some extra help or to go over any of the concepts that we looked at here today.